Yeah, here you can see the first slides, and we can go on. So let me skip or shorten the beginning because everybody of us know why we are here. We need to adapt our cities to stay livable under climate change. We try to find best solution to improve the climate. Our research group follow people-oriented paradigm. That means that we focus on thermal comfort, not only to thermal exposure, which I will talk about here, but also on physiological component and psychological component, which we presented on the poster or on the TED conference. But in my today's presentation, I will focus strictly on thermal exposure here to simplify that represented by UTCI, and in further research also we use other indices, of course, to make it more comprehensive. Well, regarding methods of this case study, for this case study, we use field measurements. Field measurements are still very important along with modeling. My colleague and several others presented modeling results during this conference. There were less contributions on the measurements, which are necessary also for models, but by itself. So we use quite a simple but reliable German Alborn technique to measure air temperature, humidity, globe temperature, and calculate mineral temperature and UTCI or Ph.D. Yeah, somebody can say the limitation regarding globe temperature. Of course, there are some limitations, but we compare that with omnidirectional radiometer. We are going to publish results soon, and I'm so far quite satisfied with the globe temperature with formula we have. So there are some limitations, but still I think the results are quite reliable. Of course, we also measure wind speed using ultrasonic radiometer, and our case study is in 5 Czech cities. I'm not going to name them. You know, probably Prague, maybe you know Pilsen because they have great beer there, like Pilsen beer, right? Yeah. You wish to have Pilsen beer this evening, but they don't have it here in Sydney, unfortunately. But back to my research. So we already published some data based on our research 2 years ago, but here I'm providing extended results, extended, more comprehensive, because we add since that many more measurements, and I can generalize already our results. So here is the daytime summary for Czech cities, and all data are in comparison with sunny pavement or gravel. So we can say that the trees now I'm generalized regardless the crown, regard type, regardless the height, during the daytime on daytime average reduce UTCI for 5 to 10 degrees. Less effect can be seen under the shading cells, which reduce UTCI for 3 to 6 degrees during the daytime. Law or turf, we had excellent presentation on the turf, and much more data are needed here. But based on our measurement, depending on the moisture, depending also on the grass height, and depending on the density of the grass, that may be also very important for your research, to focus on the density and height of the grass and its differences, because in the real urban environment there are big differences. We can observe the decrease of UTCI from 0 to 2 degrees Celsius on average. Following or moving to the artificial surface like tartan or rubber, depending on the color and character, it increases usually UTCI for 1 to 3 degrees Celsius. Here I mean artificial surfaces which are used, not some crazy black ones. Okay. Moving to the wood products or mulch, here it also depends how old is it, if it's light colored or older, like brown, how wet is it. It can increase UTCI for 2 degrees Celsius or decrease it for 1 degree Celsius. We are in this range, but here more data are needed, so there is asterisk. Fontines or small water elements in urban areas in moderate climate can decrease UTCI in the microscale for 2.5 degrees Celsius or increase it for 1 degree Celsius. That's the range. Sprinkling the road or sprinkling fountains on general decrease UTCI for 1 to 3 degrees Celsius, but one sprinkling road works only, or the effect is observable only for 20 minutes. If you repeat it, then it's much more efficient, of course. And finally, we have mist gates. Here, of course, we didn't measure the effect of the water on the skin, but only the effect on the surrounding thermal environment, so it slightly decreases UTCI. So, because I don't have much time, I'll move to the new results, which we have focusing on the night-time measurements that are quite scarce, because it's hard to organize that during the nights. So, first case study is from Prague, and here you can see I intentionally present only raw data because it's a new research. You can see that the reference station on the pavement had during the whole night higher UTCI than artificial surface on the children playground or on the turf. So the difference was about 1 degree Celsius in this case study. In the second case study, you can't see negligible effect of the water fountains, so they simply don't have effect on thermal exposure during the night. But there is one kind of water fountain which irrigate the pavement directly. It goes from the ground, and this fountain had effect, and this effect prevailed during the night because it was periodically cooling the pavement during the day. So it cooled the surface, it reduced the heat accumulation, and also thanks to the evaporation, it reduced the temperature, and this effect prevailed during the night. As you can see, despite it didn't work during the night anymore, it worked only during the day. It's sprinkling system, so it's important to know. But I know that you don't pay attention to me anymore because you can see here tree, and yeah, this conference is obsessive with tree. And indeed, like I'm not saying that trees are not important, of course, but there are also other solutions, you know. But yes, you are right. Here you can see that the tree increase UTCI during the night significantly. It's around 2 degrees, particularly in the second and third phase of the nocturnal cooling. So gladius is, I think, Latin name, if I remember well, on this tree. So it increased the UTCI. In the second case study, we have the similar story. Again, the tree significantly increased UTCI. Of course, on the micro scale, we measure 1 meter or 2 meters maximally from the tree. So again, you can see it increased UTCI quite significantly. Here, on the third case study, you can see that the tree increasing effect on UTCI is not that pronounced. Yeah, it's much lower, despite the UTCI is still higher below the tree than on the open space with pavement. But here is a grass under the tree. That's the difference, and we need more data to analyze if it's the effect of the grass or if it's some other effect like tree type. It's platanus. So more measurements going on this summer, and next summer, yeah, we need more robust data to interpret that. We want to be very careful. And I think final case study which I'm going to present here today is from Brno, the Czech second largest city. Here, what is important or noticeable is that we have semi-permeable shedding cell, and also the tree, it's a size, I think, if I remember well. And you can see that semi-permeable shedding cell increase during the night UTCI a little bit less than the tree. Yeah. So these results were expectable. It's fit well with our theory. So to sum it up, preliminary summary of our study. Trees reduce UTCI by 5 to 10 degrees during the daytime, while it can increase UTCI from 0 to 3 degrees during the nighttime. Shale sales reduce UTCI by 3 to 6 degrees during the daytime, while they can increase UTCI by 0 to 0 degrees during the nighttime, but we can remove them. We can't remove trees. Not yet. Maintain a law in open space leads to UTCI reduction from 0 to 2 degrees during the daytime as well as during the nighttime, but we need more measurements during the nighttime as I mentioned. And fountains change UTCI between -2 and 1 degree during the day as well as during the night, depending on the solar angle, type of the fountain, etc. So there is huge variability between those two elements. It's for one whole article. And sprinkling of the open spaces during the daytime reduce UTCI by 1 to 3 degrees. And if the sprinkling is repeatable during the day, the effect can persist during the nighttime. It's, I think, important note for the municipalities. So thank you for your attention. And if you are interested in our research, you can check it on research guide, or we can discuss it later. Thank you.
I think we have time for one question for Michal on this research. Does anybody have a question for him?
Thank you for.
You're on. It's working.
Okay. Thank you for good presentation. I have a question about what is the mechanism behind the tree effect on UTCI during the night time? Because I saw your result, UTCI will increase because of the tree during the night time, but this humidity will be low or something.
Regarding theory, regarding models, the effect is by long wave reflectance of the long wave radiation. The most effect is given by that.
Thank you.
Alena, we got one from Toby up there.
Thank you, Michael, for your presentation. I was going to ask, in terms of comparative analysis, did you control for temperature? In one of your case study, we saw that the effect of tree on UTCI at night is kind of negligible. However, in some other cases, it was maybe 1 to 2 K. So I was wondering whether the prevailing or the ambient temperature or the ambient condition, whether they are comparable and whether you could adjust the result based on that, so that we can make a reasonable conclusion around the effect of trees in the cases you've highlighted.
Yeah, exactly. As I said, intentionally during the night we don't have enough data to conclude it definitely, but we of course control ambient temperature and other meteorological parameters. That's why I said that we need much more management during the nighttime. But our results are already final for the daytime. For the nighttime, to explain those variability, we are continuing our research during this year, next year, and then we will explain those variability. If it's thanks to the weather condition, if it's thanks to the tree type, if it's by the law or turf. Yeah, so it's a good question, but I don't have answer yet. But I'm aware of it. Thank you.
I think we'll have to move on for now, but we should have time